All right. Give me questions about your homework. What? It is working. Yes, Kenzie, reach back there and cut the middle section of lights off. Thanks, Ken. No, not all of them. We're going to welcome. All right. You had, where were we? 1 through 10, right? All right. Any on the first section? One. Let me start with 1, but I'm not going to do them all. Pick 2 from the section, 2 hardest. 4. A lot of people have said 4. And we need one with the new equation. I am with you. All right.
They're all the new equations.
So look, they're just giving this to you a little bit differently. Your A is the same thing as saying when x equals 0. Same thing, okay? It's still the difference quotient. So the derivative at 0 is going to be the limit as h goes to 0 of, okay, f of, no you didn't. You don't, but you need to be familiar enough with it because they do throw that on multiple choice. What they'll do is they'll say which one of these would represent the derivative of the function, and they will all be in the form of the alternate equation, which you'll have to pick out. No, but that's just notation. So if you see it like that, know that that's what it is. I'm going to show you 2 new notations today also. Okay, look. What is 0 plus h? H. So this is really just h cubed plus h, yes? What's f of 0? So the limit as h goes to 0 of h cubed plus h over h. That's the limit as h goes to 0 of h squared plus 1, which would be these should have been a lot easier for you because they were at a specific point. They weren't. Okay, so let me show you that second equation because I didn't have time. And some people like the second one way better. And again, as far as, bless you, what you have to use, it doesn't really matter. Give me one from the second set. 9. 17 is not the second. All right, so it tells me, come on. F prime of A is f of x minus f of A. Why is it what? Okay, watch. This is, Logan, f prime of, what did it say? Oh, this one I didn't have. Okay, that's okay. So, f of x, I know, is 3x minus 12. I don't have an f of a, so I have to do 3a minus 12 over I think the other one's easier, but that's just because that's what I learned calculus on. This is the limit as x goes to a. I didn't put that over here. Yeah. You would have to be able to recognize it maybe for a multiple choice question where they said, which one of these represents f prime of x? And so they would give you all of these that are situated with a's in them, and they would be different ways, so you have to know which one was the alternate formula. FRQ situation, no, you've never, what? Yeah. Okay, so here I would get, this is the limit as x approaches a of 3x minus 12 minus 3a plus 12 over x minus a. Obviously the 12s are going to cancel. So now I've got the limit as x approaches a of 3x minus 3a over x minus a. That's right, because I can factor a 3 out here. A lot of people that don't understand difference quotient like the alternate formula. No, it's not, but different people see it different ways. If that makes more sense to you, by all means, use that. It's f of x minus f of a over x minus a, and you're taking a to 0. I mean, you're taking, yeah, no, you're taking x to a. Yeah. All right, number 10, which way do you want me to do it? The difference quotient or... All right, let me say this and put this somewhere in your notes. We wrote that derivative could be, if I start with f of x, the derivative could be written as f prime of x. Another way we can write derivative is we can say, if I start with y, dy dx would be the derivative. Okay? Dy dx, if you see that, that says the derivative of y with respect to x. So we can use that notation. I think that's the only other new notation they've put in here so far. It's the same thing as saying, if I found this one, it would be d dx of f of x. That's saying take the derivative of f of x. This is saying take the derivative of y. This? Yeah. No, we have. It's just notation. It's just notation. So if I told, like, look at number 10. Number 10 says y equals 7x. And they say find dy dx. They're saying find y prime. Find the derivative. That's f prime of x, same thing. They're all, this is all synonymous. Yes. Okay, so let's do it. So you want to do difference quotient or alternate? Alternate. The limit as x goes to a of f of x minus f of a over x minus a. This is the one I'm least familiar with. I have to stop and think about it for a second. All right. 7x is my function, so the limit as x goes to a. If you know the power rule, what should I get here as my derivative, Sonny? 7. All right. 7x minus 7a over x minus a.
You know what? I'm gonna have to
All right. I can factor a 7 out here right now. I'm just algebraic manipulation. 7x minus a. Do what? You want me to do it and show you? Sometimes some are easier than others. It just depends on the... I don't think it's any harder. Well, right now you're just taking linear functions, and the derivative of a linear is always a constant. So it's going to be easy in any one you do. All right, what else? What else? What else? 18. Y equals 2x squared minus 13x plus 5. It says use this to find the equation of the line tangent to the curve at x equals 3. To find an equation of a line, I need two things. What are the two things? Point and slope. It doesn't matter. Even back from whenever you were in algebra 1, you needed a point and a slope. You still need a point and a slope to find an equation of a line. So, I need a slope. The point's easy, yes? I plug that in, I find the point. So y of 3, I don't know what that gives you. 9, 18 minus 39 plus 5, what do you get? Negative 16. Are you sure? Yeah. Okay. It's not positive 16? Okay. All right, slope. How do I find the slope of the tan line? Difference quotient. Every time that's your answer. Slope of tan line, difference quotient. Shut up. What? I'm sorry. Want to use the alternate? You can use either one. Either one, they're doing exactly the same thing. If alternate formula is your cup of tea, then do alternate formula. Okay, let's do difference quotient. Let's do difference quotient since that's what we started with. I find that it's easier for me, but again, that's how I learned derivatives was difference quotient. We didn't have the alternate formula. If we did, it wasn't taught because we didn't have to. All right, f of x plus h. 2x plus h squared minus, and actually it's not x. I need to change that. Plus 5. So yeah, I'm going to change all these x's to 3's. Right? All right, what do I have? 2 times 9 plus 6h plus h squared minus 39 minus 13h plus 5. Yeah, you'll have more work, but that's fine. Absolutely. Let's see, Kenzie, hush. 18 plus 12h plus 2h squared minus 34 minus 13h. I heard the whispering. And I looked up to see who was doing it in the middle of writing, and is this what y'all got? Minus h 16? What? Missing what? This is 18. 9 plus 6h plus h squared. 39 minus, this is what you got? Okay. Maybe because y'all didn't plug in until the end. What happens when you plug in 3? All right, so I end up with limit h going to 0 of 2h squared minus h minus 16 minus negative 16 over h. This, and this. So I got 2h minus 1. Is it negative 1? Don't just cross that 1h out by itself without holding its place with a 1. See what I'm saying? When you get here, 2h squared minus h over h is going to be 2h minus 1 over. Are y'all with me? Where did I lose you? Plugging in what? Okay, so f of 3 plus h, that's what I've done here. So that, I just came over to the side and did f of 3 plus h on my own. And then whenever I got it, I plugged it into this equation here. Right? Like I worked it out and then I plugged it in. I just didn't work it out in the equation. I worked it out off to the side. Does that make sense? Okay, so like I foiled this out to get. Does that make sense? It's just a whole lot of algebra off to the side. Yes, ma'am. Yes. I'm sorry. I'm sorry. It's because I come off to the side because I'm trying to. I still haven't answered the question. So that's why I come off to the side and do it. Did y'all hear the question? Because this is a question that I know you'll complain about getting your point. If I come off to the side, I don't have to keep writing the limit over and over and over again because really I'm just coming over to the side to do this, right? Whereas if I keep it in the problem, I would need to write the limit as h goes to 0 of, and I'd have to keep writing that different question as I go down. So it saves me a little bit. Let's write the equation of the line. Y minus y1 is plus 16. Negative 1's my slope. Negative 1 x minus 3. This is the tan line. It did not ask you this, but tell me what is the equation of the normal line? Did it? All right. All right. Logan? If he throws anything else, go out the door, knock on Coach Beck's door, and tell him to come here a second. All right, one-sided derivatives. No, we're still doing the same thing that we've been doing. So if you don't quite get it and it's not sticking, we're going to keep practicing with it, okay? But I want to talk about one-sided derivatives, and I want to talk about derivative graphs for just a minute, and then we'll be done for today. All right, one-sided derivatives. You know calculus loves a piecewise. What does this graph look like? Right? It is. So it's a piece of the parent. The x squared is a parent graph of a quadratic, right? That's easy. So when x is less than 0, like that, it's a quadratic. But when x is bigger than 0, so it looks something like this. If I asked you to find the derivative at 0, now remember, a derivative is what? What's a derivative? What does it mean to be a derivative? Hi, Coach Collins. Please get this right. What is a derivative at a point? Slope of the tan line at that point, right? If I find the derivative at this point, then I am finding the slope of the line that goes through that point in just one place, right? Okay. If I ask you on this graph to find the slope at 0, do you notice or do you agree that it's going to be different depending on the direction in which you come? So we have to look at this as a left-hand derivative and right-hand derivative. And here's how we're going to do this. We're going to approach the left. This is only with piecewise, by the way. Left-hand derivative. The limit as h approaches 0 from the left of f of x. And then, yes, you do. You do. That's why I said we're still going to be doing the same thing. So from the left, I'm using this equation. So I'm doing the limit as h goes to 0 of f of, remember I'm doing it at this point, right? So f of 0 plus h minus f of 0 over 8. Okay. What? Oh, yeah. Sorry.
On the left, we're always looking at the
Mm-hmm. Now, the one from the left, well, it depends on the way this inequality, yeah. Now, for the derivative to exist, I probably should have started with this. For the derivative to exist, you're gonna, this makes sense because you know about limits. To exist, the limit from the left has to equal that I shouldn't say the limit, I should say, I'm going to say the left-hand derivative has to equal the right-hand derivative. If they don't equal, in other words, if the slope coming in is not the same, then slope has to be the same from both sides in order for the derivative to exist. It's not going to be the same, but we're going to show that. You're exactly right. It's not going to be the same. Because you'll have to prove. All right, so let's look at 0 from the left, right? I'm using the x squared. So the limit is h goes to 0 from the left. I've got h squared minus 0. F of 0, remember my f of x in this case is x squared. I didn't do it out to the side this time because y'all said that was confusing. Is that better? This is this. And then I plugged it in back here. If it's h squared over h, what does that give me? And if I plug in, what's the left-hand derivative? 0. I needed to match the right-hand derivative. So as long as the right-hand derivative is also 0, then the derivative is this. If it doesn't, then my derivative is set them equal to each other. Set what equal to each other? Yes, so if you have h minus 0 and you plug in 0 for h. All right, right-hand derivative. That was the left hand, right? All right, right-hand derivative. This time, I'm doing the limit as h goes to 0 from the right of f of x, which is f of x plus h minus f of x over h. I'm at 0. I'm not at 0 because of this 0. I'm at 0. I'm at 0 because that's where they asked me to find the derivative, guys. The other half did a lot better with this than what y'all are doing. All right, f of 0 plus h would be 2h. No. F of 0 is 0, but whenever I plug in here, let's see, 2h minus 0 over h. So, the question was asked, why am I doing this? What is going on? Well, I am doing this because I need to see if they equal. If they equal, that is the derivative at the point. If they do not equal, D and E. Yay! So this is D and E because they're not the same. This is probabilities of shared birthdays. This is on page 109 in your book. You don't have to worry. I just wanted to show you because one of your homework problems looks like this. To find the derivative, all right, remember derivative is the slope of the tan line. It's the slope at a point, right? Say right. Right. All right. So if I want to estimate derivative, because it makes me call something at least. If I want to use a data set, okay, because a lot of stuff we do in here, we use tables for things. If I have this data set and I want to estimate the derivative, I'm going to use AROC to estimate IROC, okay? And what I mean by that is, if you look, if I use these two data points, yes, y'all with me? I find the midpoint of these two to be 2.5. That's going to be my new x. Then all I'm going to do is find the slope between these 2 points to find the estimated derivative. Does everybody understand what we're doing? What is AROC? Okay, give me a more basic definition of AROC. The slope between 2 points. What is IROC? The instantaneous rate of change. which is at a point. But remember, I can't find at a specific point, so I have to go to two closest and try to close that gap, right? Y'all follow? Y'all tracking with me? If I have a table of values, I don't have an equation to close that gap on. So what I have to do is take the two numbers closest to that point. So for instance, on this one, if I'm here, if I want to estimate the IROC of 2.5, because I'm going to go in the middle of these two, I'd do the actual slope from 0 to 5. So 0.027 minus 0 divided by 5 minus 0, and I would get this. This is an estimate of the derivative of this set of data.
Like, I understand what you're doing with Y.
Because I might get a question that says, what is the approximate derivative, or better yet, since this is people in a room versus probability, right, in my X and Y, what is the rate of the probability per people in the room? You are. This is exactly what you're doing. I'm not. I said use AROC to estimate IROC of midpoint. Do you know how to find the derivative from a set of data? If I asked you what's the derivative at 2.5, what would you tell me? You would have to do, right, because I don't have, that's the only way to do it. So that's why I said that. Well, you don't have a Y value for 2.5. This has not been given. Busted. So the 2.5 is coming from the midpoint of these.
Yeah, but like, why are you using the Y value for those?
What do you mean?
Like, if you have the one for 5 and 0, why is that the right way?
Well, because I'm taking in the middle of these two, right? And then I'm using these 2 points, this point of 0, 0 and 5.027 to do the slope between those two to get that value. Oh, sorry, I went one. The difference between 5 and 10. Yeah. So your new X value, this is your new derivative estimate chart.
Okay, why would we use
Yeah.
the midpoint of 0 and 5?
Because derivative is all about rate. This is not giving me a rate. Remember, for rate, I need to do change in Y over change in X. So I'm trying to estimate derivatives. I'm trying to estimate rates. So I'm not going to use in the middle because this is not a rate as it is now. Remember, your rate is per, like if I needed feet per second. If I just did the Y's, then that's just in feet. That's not in a rate of feet per second. So to get it in the rate or the derivative form, I have to do the slope formula. Yep, it's just this minus this over this minus this. No matter where I go, if I go down here to this last one, what's halfway between 65 and 70? 67.5. To find the rate, the approximate rate at 67.5, I would do 0.999 minus 0.998 over 70 minus 65. And that's this value. That's my rate. I'm estimating. That on the right is using AROC to estimate IROC. And yes. And those are questions all the time on FRQs where they'll give you a table. It won't be this big. It might have like 10 values in it. And it'll say, what's the approximate instantaneous rate of change at 5? 5 won't be in there, so you'll have to pick the number closest below it and closest above it, and you'll have to use AROC to estimate IROC. Yes. And they give you a table of values. All you're doing is making a table of slope values. That's all you're doing. I only have one of those. Midpoint slope.